Hello and welcome to the session on sensor technology. In this session, we'll have an overview of sensors. We'll look at some of the key sensors, their characteristics. We'll deep dive into few sensors and their applications. Thank you. To start with, let us look at some of the popular definitions of sensors. The Dictionary of Telecommunication Standard Terms defines sensor as a device that responds to a physical stimulus. The physical stimulus could be thermal energy, such as temperature. It could be electromagnetic energy. It could be acoustic energy from voice signal. It could be atmospheric pressure. It could be a magnetic field or a motion by a human being. It produces a signal as an output, which is usually electrical. Another definition says a sensor is a device that receives a physical stimulus and responds with an electrical signal. This is from a handbook of modern sensors by Fraden. The third definition is very interesting. It is very simple. It says it's an electronic device used to measure a physical quantity such as temperature, pressure or loudness. It converts that to an electronic signal. To summarize, a sensor senses a physical phenomenon and converts that to an electrical signal. Now let's get into further details on sensors. There are a lot of popular sensors that are available, as you see in the picture. You got the ultrasonic sensors, the temperature sensors, the atmospheric sensor, and so on. So let's look at some of them. The first is the temperature sensor that measures the ambient temperature, and there is pressure sensor that measures the atmospheric pressure, and the humidity sensor measures the relative humidity as a percentage. We got the ultrasonic sensor that measures the distance of an object using ultrasonic waves, the light sensor that measures the intensity of ambient light. Moving further on, we've got soil moisture sensor that measures the content of water in the soil, the proximity sensor that senses the presence of a human being or an object close by, an accelerometer sensor, this is commonly used in mobile phones, that measures the movement. The gyroscope sensor, again, that is used commonly in mobile phone for detecting the rotational moment. The Hall effect sensor that measures the magnetic field. The gas sensor that could be used for measuring the presence of gases. So these are some of the popular sensors that are used. There are a wide variety of sensors further on that are used in several IoT applications. Let us look at how does a sensor function. As an input, the signal from the real world is typically analog, as we've seen earlier, and an analog signal needs to be converted to an electrical signal for processing by digital systems. So the first component that is used in the process is a transducer. A transducer is one that converts a form of energy into another form of energy. The transducer that is used in a sensor converts the analog signal into an electrical phenomenon. It could convert the voice into an electrical output. Now, typically, the converted electrical output has several set of frequencies and the voltage at levels that may not be good enough for an ADC to convert. So the signal needs to be gone through what's called a conditioning process. It could be amplifying the signal to match the ADC's input range of voltage, which also improves the resolution and the sensitivity of signal. It could also attenuate the signal to the voltage level that is required for the ADC range. Then comes the analog low pass filter. Again, as we see, there are several signals at different levels of frequencies. We need to remove the noise component of the input analog signal, and we need to remove the high frequency signals. Otherwise, if they are present, it's going to yield wrong results. So this also reduces overheads in further processing. Then finally, the analog to digital converter, which is the ADC, that is used for converting the analog signal to the digital equivalent. This enables processing by digital systems and fed to the digital systems such as microprocessors. So as you see, a real world event or a physical phenomenon comes in as an analog signal and gets converted to an electrical measurable output such as a digital signal. To summarize, we had an overview of sensors in this lesson, and we also looked at some of the common sensors and their applications quickly, and then we had a look at how a sensor functions. We will get into further details in the upcoming lesson.